Hello everyone. After all these hacks, I'm going to try to explain how to prevent them. My name is Charles Guillemet. I'm CTO at Ledger, and my talk is called From Chaos to Confidence, Understanding and Predicting Transactions. And at the end of the presentation, there will be a small bonus. So, who in the room owns a Ledger wallet? Raise your hand. Okay, almost everyone. And who is in the room as always, like blindly sign hash? Raise your hand. Almost everyone. Also, then that's not that good. It's very risky to blindly sign hash because you have no way to understand what it means. Maybe you are signing the transaction you intended to sign, but maybe you are signing away your assets. When you see a hash, there is no way for you to understand if it's a legitimate operation, if you are like interacting with the right smart contract, or if it's an unintended authorization or a malicious payload. That was said right before. There are plenty of hacks out there. WazirX was the biggest one last year, and this year, unfortunately, we saw Bybit hack. So they lost more than 1.4 billion USD, which is the biggest hack ever. And for me, there are like several takeaways. I think the first one is that like when you are a financial institution, like a big organization managing like that much money, you shouldn't rely like on 3 devices that cost like 79 USD. Like I don't think it's something wise to have this kind of budget to secure 1.4 billion. And the second thing is understanding the transaction that you are about to sign is really paramount. This is the only way to fix this. So clear signing fix this. What is clear signing? Clear signing is the power of information. Here you have like an interaction with 1inch, which is a clear sign. And as a user, you completely understand what kind of transaction you are about to sign. You are interacting with 1inch fusion swap, and you are about to swap 1,000 WMATIC to 554 USDT. And then as a user, you will decide if it was the transaction you wanted to sign or not. It's completely transparent, human-friendly, and it really like empowers user. To implement clear signing, this is not that easy because the device itself is not connected to the blockchain, and it receives like a raw transaction, and it's very complex for the device to understand how to parse the transaction. So in order to solve this, we have created a standard, which is the ERC 7730, which consists in creating a high-level description on how the smart contract is working. So we are working with dApps. dApps are going to create a JSON file that describe on a high-level mode how the smart contract is working, what are the name of the method, what are the parameters, and so on. So the idea is to create this JSON file, to submit it for review to our GitHub repository. And then we have all the information that are necessary for the device to understand the transaction. On the wallet side, it's supported within Ledger Live, and if you are a wallet and want to integrate this specific feature, you only have to integrate the device SDK and partner with us in order to make this a reality. The device management kit is a high-level library that allows to discuss, to communicate with the device. You can discover different devices. You have the connection. You can exchange data. You also have like state management and OS command. So it's a high-level library that really is the process of integrating Ledger devices into your stack. Let's go into like a very successful implementation example. So I'm going to walk you through the clear signing for Aave. So we have created a tool that really is the process of creating this JSON file. And if you are an Aave developer, you're going to this tool, and you will input the address of your smart contract. You will also give the information of the owner of the smart contract, Aave, the name of the developer, the URL of the dApp, And then the tool will detect automatically the ABI of your smart contract, and then you will be guided through the tool in order to provide the name for the method, the name for the attribute, the parameters, and also the type of the parameters, so that the device can properly parse those parameters and display them on device. And at the end of the process, the JSON file is created by the file. You only have to submit it on our GitHub repository. So the GitHub repository is hosted by Ledger today, but it's intended to be a public good, and we are really happy to decentralize it. If the Ethereum Foundation wants to use it, to host it, we will be happy to do so. And when the JSON file is submitted to the GitHub repository, then we are doing a curation process. We are verifying the JSON file and that it matches with the smart contract. And finally, we are signing it so that our devices can recognize this JSON file. And whenever you are interacting with Aave, the device receives the raw transaction to be signed along with this JSON metadata file. And then the device is able to understand how to parse the transaction and how to display the necessary information for the user to decide if he wants to interact with Aave. And then you have the name of the contract, you have the amount to borrow, and everything necessary to take a decision. So if you are a dApp developer, it really takes like 15 minutes to create this JSON file. Then we will need a few days to review everything, and then you are providing clear signing to your users. So if your dApp is not clear signed yet, please take those 15 minutes. We have started with EVM and Ethereum, but the idea for us is really to clear sign all the things. So we are continuing discussing with different dApps to make sure that we have this JSON file, and we are going to expand the methodology to the different chain in the ecosystem. So clear signing is something very important, and it would have avoided like all these hacks that we have mentioned. And to the safe specific smart contract, which is a little more complex, we will have like more enhancement to do like in the near future. Just a teasing. We are working on creating a security layer in order to clear sign safe. But sometimes it might not be enough because with clear signing, what you have is an understanding of what you are signing, but it doesn't give really like information on the risk for the transaction you're about to sign. And that's why we have created a transaction check on device. So the idea is to give to the user with like a risk assessment for a specific transaction, but on device. And it's really important that it happens on device because if it happens on your smartphone or on your computer, you might think like the transaction that is simulated can be one, and the transaction that you are signing can be another. And this is exactly what happened to WazirX and Bybit. On their front end, the transaction was simulated, everything looked fine, but they signed another transaction. So that's why it's important that this transaction check happens on device. And it's really like complementary to clear signing. Again, the device is not connected to the internet, so there is some magic behind this. The way it works is pretty simple. When you are about to sign a transaction, you're going to connect on Aave or on your favorite wallet. Then the transaction is crafted. And before sending the raw transaction to the device, it's sent to a third party that are specialized into a risk assessment for a transaction, mentioning like Blockhead, Cybers, and Tenderly. And they do their magic, meaning that they do transaction simulation. They conduct a risk assessment with their own heuristic. And then they provide like a risk assessment report that will be given to the device. And then on device, you are receiving the raw transaction to be signed with the JSON file in order to clear sign it, plus this risk assessment report. And on device, this is what you see. If the transaction, if no threat is detected, it's verified, like nothing is displayed on device. And if a threat is detected, then you are prompted with this screen. You can't miss it. Like it's very, very obvious. There was a critical threat detected. And then it's up to you. You can like be back to safety, meaning you don't sign the transaction, or if you feel lucky today, you can accept the threat and continue. Again, like what we want to do is really to empower user, but at the end, users take enlightened decision with the information that we are providing them. So if they really want to sign this risky transaction, it's still possible. And we launched this specific feature only 2 months ago. It's only available on Flex and Stacks. And in 2 months, we prevented 20 million in losses. So it's already very big, especially like if we compare to the time it's live and the number of devices it concerns. So if you don't have a Flex and Stacks, I really like encourage you to have one in order to benefit from the clear signing and also to the transaction check on device. And this number will continue to increase over time, no doubt about that. So we are really like preventing hacks on the field. A couple of useful links. If you are a dApps and want to be clear signed, don't hesitate to scan the QR code and provide your JSON file to be clear signed. If you are a wallet or a developer, there are also the corresponding QR code that can be useful. As I mentioned, I have a small bonus. We also have announced the Ledger Recovery Key recently, and the Ledger Recovery Key is an alternative for your backup. It's a small NFC card, and so now you know probably the recovery sheet. I still advise any user to have a recovery sheet with the 24 words to store this recovery sheet inside the secure location, maybe a safe in a bank or anything. We also launched Ledger Recover 2 years ago. It was a famous launch, and it's an online distributed backup that you can enable by proving your identity. Really cool product, and it's a paid subscription. So if you really don't like this product, you don't have to pay for it. And today we are announcing this new product, which is Ledger Recovery Key. It's a small NFC card, a squared one. Easy to pair and use. You will unlock it with a dedicated PIN, and you will interact with it using your Stacks or Flex. Again, at Ledger, we never compromise with security, so it was designed with a very high level of security in mind. The NFC card embeds a secure element. Inside the secure element, we have built our own application, which is that you can review it on GitHub. And then we are mounting a secure channel between the Flex and the NFC card, the recovery key card. This secure channel gives you like a mutual authentication guarantee, meaning that the card proves it's a Ledger One, Flex proves it's a Ledger device, and also the card proves it's this one. There is a pairing code, exactly the same type of experience that you have on Bluetooth, so that you are sure that you are discussing with this specific card and not another card in the room. So everything is really secure. Then you input the PIN to unlock the card, and then you will allow your 24 words to be backed up into this card. There is a wipe mechanism, meaning that if you input like 3 wrong PIN for this NFC card, it will be wiped. You can use like multiple cards if you want to swap from one card to another. It's very easy and very convenient to back up and restore. So I'm really happy to announce it today. So that's it for me for today. Thank you for your attention. And if you have questions, I guess we have some time. Any question in the room?
Thanks. Yeah, maybe I missed it, but why is NatSpec not enough for this service? Like, why does the developer needs to interact with the system to provide the JSON file?
What is not enough?
Not spec, like the inline documentation of smart contracts or.
So yeah, with the ABI, you will have we'll have some name of the method, but sometimes you don't have the type of the attribute and the attribute and the parameters for the method, and also it needs to be provided by the developer so that we can curate it. But there are other sources. But what we want is really to create like a partnership with DApp so that we have their information and they are responsible for it. But yeah, there are many sources. The question is to trust the source and also to have the right format for our ERC 7730. Any other question in the room?
Thank you for your talk. About the NFC card you just presented, is it protected against the NFC readers like the 3.0 device or stuff like that?
Yeah, as I mentioned, like you have like the NFC part, which is like only the communication channel. But on top of this communication channel, we have created our own secure channel that is authenticating both parts. Meaning that the card has like a cryptographic guarantee that is discussed with a flex, and the flex has a cryptographic guarantee that is discussed with the card, and also with this specific card. And as soon as this authentication is established, then they are sharing a secret to encrypt everything between the card and the device, so that it's end-to-end secure.
Thank you.
Any other question?
When you send a transaction to the third party for simulation, where is that request initiated from, and how do you verify on device that it was an authentic simulation?
Yeah, very good question. So this call happens is performed by the device SDK. So the device SDK is the layer between the device and the wallet, and the device SDK will create this request to Blockhead, Cyverse, and Tenderly. And then the risk assessment report is signed by Blockhead, and inside the report there is the hash of the transaction and the signature by Blockhead. The device will receive the raw transaction and the risk assessment report. The device will verify that the risk assessment report was signed by one of the third parties that we mentioned. And secondly, it will verify that the risk assessment matches with the specific transaction in order to avoid the kind of attack you mentioned. I see a question at the bottom.
When you have a safe, calling a time lock, calling a contract in more complex setup, how do you do clear signing in this case? Do you have nesting of the calls? Do you analyze the subcalls? So
this is the challenge that we are working on. The safe is a little more complex than a regular smart contract because you can do the nested transaction and embedded call data and so on. And we are working on this. I don't think we will do like a recursive thing so that you can like sign a transaction inside the transaction inside the transaction. But for safe, for one level, it will work. This is what we are working on. Any other question? Okay, cool. Thank you.